This lesson is to show an example of how to do a subtraction problem using the method of counting up. And the first thing I'll say about subtraction by counting up is that it's a great technique. It's an alternate form, an alternate method for doing a subtraction problem that isn't necessarily appropriate every time you do subtraction. Even if you like it, you kind of find when it's a good idea and when it's not. And so I'm going to start with one it's a good example because it shows the kind of things that you want to do, but it's not necessarily the most appropriate example. Like there would be ones that would be even better to do. So after this video, and I probably won't have time right now, but after this video I might make a couple of other ones that are really illustrating when it's a great idea. So I'll show traditionally what you'd look at and by counting up. But the problem that I'd like to use as the example is 72 3/100 minus 14 78/100. And so the idea is that you are thinking of this subtraction problem, here's the result that I'm looking for, as the missing piece in an addition problem. Here it is, this 72, take away 1478, and what do you have left over? But that's equivalent to what do I add, or what more do I need in addition to 1478 to reach the total 7203. Here there are two parts that you're adding to get a total, and here you're starting with the total, taking away one of the parts, and trying to figure out what the missing part is. But those are really equivalent ideas and just a different way of imagining what that result kind of means. Some books and some classes call this a family of, or part of the same family of problems. The relationship between these two numbers is really the equivalent, and it's just a different way of looking at it. All right, so let's get straight to the how-to. So you start with the number that you're taking away. So I've got 1478, and in each step of counting up, you start at the lowest place value that has anything in it. So in this case, the hundredths place, and you count up. So I have 8, 9, 10 gets it to a round number, so that there would be a 0 there. So I'm going to add 2 hundredths, and so I got to be careful when I'm doing that to realize I'm not adding 2, I'm adding 2 hundredths, and to notate that in your step. But you're thinking about, okay, so 1478, 79, 80, where you land after adding that is 1480. And then to fill the next place value, and I'll do that in another color, to fill the next place value, Dodger blue, let me erase that. Eraser, there we go. Let me erase, whoa, didn't do the eraser, made more Dodger blue. Oh my goodness, start over. Those of you who understand and are Giants fans will really understand why I went through all that trauma. But let's go to orange. So now we're on the 10th place, and so I'm thinking, okay, 0.8, 9, 10. You're counting up to make a whole, fill in that place value in a sense. And so, 80, 90, $1 if you're thinking money. But I'm adding 2 tenths or 20 cents, and now reaching 15 even. From there, now I'll go to green. Now I'm going to fill in the ones place, so I'm going to add 5 ones. So 15, 16, 17, 18, 19, 20. That was 5 I had to add to get 20. And now I'm on the tens place, and if I think back to what the original total was, it was 7203 that I was taking away 1478. I'm trying to figure out what the heck that is. So now I only need 50 more to get to 70. So I don't need to fill in all 80 more to get to 100 because that's past where I need to go. So I'm going to add 50. I was supposed to do that in red. Sorry. Go back to red. So I'm going to add 50 because you've got 20, 30, 40, 50, 60, 70. 50 more gets you to 70. And now the last little bit is the 203. And so I don't need to do those one place value at a time because it's pretty easy to think about. If you already have 70, you only need $2.03 more to get to 7203. So I'm almost done. I've started at the 1478. I added 2 cents to fill it in to get 1480, and then I added 20 cents to fill that in and get an even $15, and then I added $5 to get an even 20, and then I added $50 to get to an even 70, and then that last little $2.03 fills in the rest. I had 70, now I have 7203. But remember, and I don't know if this works, I think so. Nope, it doesn't. What I'm trying to do is go back to the previous page. Oh, how about this? So sorry, I'm learning how to use this program as I go. So that was a 5. Back here, remember, we're trying to figure out what is the result, or what is the total thing we added to get up to 7203. Starting at 1478, what's the total amount we have to add to that to get 7203? And so I have to total all my jumps, all the little pieces that I added. I have to total those up and see what I have all together to get to 7203. And so that's what I'm going to do. I'm going to add them up. And if you look at it, it's pretty easy to add 5522 just by putting those place values where they go, those digits, in a sense. You know, those are values. They correspond to digits in a place value. And so the 55, let me go back to black, the 5522, pretty easy to do in your head. And then, if you get the idea, and then you just add the last little jump to that, and there is your final answer, quote unquote. And I'm going to check that. I'm going to check that, not by subtracting traditionally, but I'm going to check that by seeing, really, is 5725 what you need to add to 1478 to get up to 7203? Is really 5725 plus 1478 truly that's 7203? And let's see, 8 plus 5 is 13, carry the 1. 7 plus 2 is 9, 1 more is 10, carry the 1. 7, 8, 9, 10, 11, 12, carry the 1. Sorry, that was a big carry. And then 5, 6, 7, that 1 that we carried. Yep. And so we added back to check. And I know that's a lot of work to get the answer to a subtraction problem, but you're in it the whole time. You're thinking about what you're doing. There's not really, once you get the sense of how this works, it's not so much you've memorized it. It's like, okay, I get what I'm doing here, and I'm making sure everything's working out right.